Hello everyone and welcome to this lecture of NFPA 58, the Liquified Petroleum Gas Code. Today we're focusing on one of the most critical fire safety standards in our industry, NFPA 58, the Liquified Petroleum Gas Code. This code governs every aspect of LPG gas from storage and transport to installation and use. And it also forms a vital part of Bahrain Fire and Life Safety Code, which is recently established in 2025, ensuring both our national practices align with international NFPA standards. Throughout this session, we'll explore its history, applicability, key definitions, general requirements, and major hazards. My name is Captain Engineer Salman Salah Al-Buflasa. I'm a certified fire protection specialist. All the way back in the history, NFPA 58 was first adopted in 1932, making it one of the earliest NFPA codes dedicated to liquefied petroleum gas. In 1940, NFPA combined several separate standards into one unified code, officially establishing NFPA 58 as a single reference. For example, in 1974, or prior to that, there were three separate documents, the ANSI Z21.30, which is now the NFPA 54, ANSI Z83.1, which is now NFPA 54A, and SME B31.2. In 1974, these were merged into one unified document under joint sponsorship of the American Gas Association and NFPA, creating a first complete fire gas code. Over the years, it evolved to reflect new technologies and lessons learned from incidents. For example, in 2011, it introduced cathodic protection for underground containers and removed obsolete valve piping rules, prohibited non-ASME railroad tank cars. In 2014, it added vehicular barrier protection, harmonized container requirements, and expanded personnel qualifications and cathodic protection for piping. 2027 addressed hot air balloons, updated snow load and vehicle impact criteria, added Chapter 12 for mobile LP gas systems, and centralized fire extinguishing rules. In 2020, it added fire-resisting material criteria, revised extinguisher user guidance, and included inspection rules for CGA connections. In 2024, it added Chapter 16 for food trucks, clarified scope for LP gas industrial process, updated horizontal container installations, and consolidated emergency remote shutdown requirements. So, codes must adapt to new risk, technologies, and user practices. Administration Overview. Chapter 1 of NFPA 58 covers the administrative framework of the code. It defines the scope, applications, retroactivity, equivalency, units, and enforcement. It applies to the storage, handling, transportation, and use of LPGs, and the LPG properties, and the federal regulations reference, which is the DOT regulations 49 CFR for transportation. So, NFPA 58 applies to any system involved in storage, handling, transportation, or use of LP gas as a fuel. That includes cylinders, piping, and containers used to supply LP gas, systems serving industrial and commercial operations, transportation vehicles, and marine terminals receiving LP gas for distribution. But for every applicability, there is also exemptions. It does not apply to natural gas refineries or petrochemical plants, chemical process facilities using LPG as a reactant, utility gas plants under NFPA 59, and systems already covered by NFPA 54 or transportation regulated by the Department of Transportation. Here we have Arad LP gas explosion, which occurred in last February in 2024. This happened in my country, in the Kingdom of Bahrain. So, on the 12th of February, a restaurant in Arad exploded after an LPG leak accumulated in the kitchen. The upper floor illegally used as labor accommodation, which collapsed, causing 2 fatalities and several injuries. Investigation found flexible hose leaks and absence of automatic shut-off valves, no gas leak detectors, and unapproved occupancy conversions, and lack of valid civil defense clearance, which is the AEG. The restaurant opened without the approval of the AEG, and the entire system of gas was not approved or listed. So this incident clearly illustrates why enforcement of NFPA 58 and 54 and Bahrain 2025 code is absolute essential. Retroactivity and equivalency. Retroactivity means new code provisions apply only from the effective date forward. Existing system may continue use in service unless the AHJ identifies a condition creating a hazard. A full compliance is impractical. The AHJ can approve equivalent protective measures. So equivalency allows alternative systems that are equal or superior in strength, durability, and safety. So in order to gain approval, documentation and performance evidence must be submitted to the local AHJ, which should provide flexibility while maintaining safety. Chapter 3 provides all definitions used throughout NFPA 58. General definitions would define the scope of terminology. NFPA official definitions apply across all NFPA codes and standards, and general definitions which apply specifically to NFPA 58, the LP gas code. Terms like container, cylinder, and dispenser have specific meaning under NFPA 58 that may differ from general use. So, first and most important thing, what is an LPG? Liquefied petroleum gas is commonly propane or butane, is a gas at ambient conditions that becomes a liquid under moderate pressure. It is colorless and odorless. Therefore, ethyl mercaptan is added for leak detections. Because its vapor is heavier than air, leaked gases tend to settle in low areas, forming explosive mixtures. And when we talk about flammability limits, we're referring to the gas concentration range in the air that can actually ignite. If the gas concentration is below that range, it is too lean, meaning that not enough fuel to sustain its combustion. And if it's above the range, it's too rich, meaning that's not enough oxygen to burn. So specifically for LPG, which is mostly a mixture of propane and butane, the flammability range is between about 2% and 9% by volume in air. That means if the air is in the room or area contains LPG within 2 to 9% range, even a small spark or static discharge can ignite it, leading to conflagration or detonation, flash fire, explosion, depending on how confined the space is. This is exactly what happened to Arad explosion. The entire restaurant was filled with gas and some spark ignited the whole building and made it catastrophic, which resulted in 2 deaths and 6 injuries, as if I remember. So this is exactly why NFPA 58 requires authorization, so we can smell leaks long before the gas reaches that 2 to 9% limits. And that's why gas detectors are usually set to trigger at around 10-20% of LFL, which is roughly 0.4% gas in the air, providing early warning before conditions become dangerous. And we have the ANSI, the American National Standard Institute, the API, the American Petroleum Institute. Bulk plant is a facility that stores LP gas in containers of more than 4,000 gallons of water. And CGA is the Compressed Gas Association. A container is a generic term for any vessel, cylinder, tanks, and portable tanks used to store or transport leak gas. All fabricated should be under SAME or DOT standards, and it is used broadly in code text when the type is not specified. A cylinder is a portable container of 1,000 pounds or 454 kilograms or less. It's commonly used for domestic and industrial uses. And dispenser is an assembly for transferring LP gas into smaller cylinders or vehicle fuel tanks. Pressure relief devices is automatically opens to prevent rupture and excessive pressure. And we have the most important stuff, the emergency shutoff valve. It closes manually, thermally, or remotely during an emergency. And the backflow check valve prevents reverse gas flow. Water capacity is the amount of water at 60 Fahrenheit, 16 Celsius, required to fill a container. It is used to express size of cylinders or tanks. Chapter 4 establish fundamental safety requirements for all LP gas systems. It covers containers and components, authorizations, temporary installations, personnel training, and fire protection, materials, and shutdown devices, which ensures every LP gas system from small cylinders to bulk containers, bulk plants is installed, operated, and maintained using approved equipment and safe practices. So, regarding containers and safety components, approval. All containers and assemblies must use approved components. Acceptance relies either to be the full system or individual parts. Cylinders less than 120 gallons, valves, regulators, connectors, and relief valves must meet specific design listing. ASME less or equal to 4,000 gallons, complete assemblies with pressure regulations and safety devices. SME more than 4,000 gallons, equipped with redundant relief and gauging devices. Also, repair and alteration must only use approved replacement parts. Field welding or unapproved modifications are strictly prohibited. Authorization. All LP gas systems or all LP gases must be authorized so that the gas is detectable at 1/5 of the lower flammability limit. Ethyl mercaptan is the standard odorant. Why? It's extremely strong and unmistakable odor at trace levels. It's chemically stable and compatible with propane and butane. It's also detectable long before gas reaches the flammability limits and complies with NFPA 58 and DOT or ISO standards. It's also cost-effective and proven in global LP gas operations. There are also other odorants such as thiophane or triterbutyl mercaptan, but they are typically used in methane systems or LNG, not LPG. And the ethyl mercaptan is best used under LPG conditions because it does not condense out easily, does not polymerize, and retains odor strength even in cold or humid environments. And it's also because it's detectable after long storage or use, unlike some sulfur components that break down or fade. It maintains its odor intensely even after long storage or partial evaporation. And economically, it's not expensive. It's always readily available and easy to meter into bulk LPG systems. And only a few millimeters per cubic meter of gas are needed to meet detection requirements. And every batch load into cargo tanks or cylinders must be documented and verified before release to consumers. And there's also an exception. Exceptions all apply only when odorant would interfere with chemical or manufacturing processes. Training. Training is required for everyone who transport or install LP gas systems. Should be trained on safe work practices, LP gas hazards, emergency response, supervised on the job training, and competency assessment. And refreshment training is required every 3 years, and competency record must be kept for each AAG audit. We require for every company to have a record of the training for every staff. Portable fire extinguishers must meet NFPA 10 minimum ABC ratings, but they are not to be used on pressurized LP gas fires until the gas supply has been isolated. Emergency remote shutdown device must be located 20 to 100 feet from transfer points, positioned along the egress route unless as specified in Chapter 10, and should be clearly labeled. As for the temporary installations, temporary systems such as those for construction site heating must be reported to the AG before installation. Installations exceeding 12 months require new approval. These refuse prevent temporary systems from becoming long-term fixes without proper safety evaluation. In the Kingdom of Bahrain, we allow no more than 40% of the container, tank, or whatever temporary installation they have in order to restrict temporary installations because the building is not yet ready for fixed installations, and we correspond with local gas filling companies to prevent them from filling more than the allowed, which is the 40%, until they finish from the temporary and get the fixed installation permit. So, NFPA LP gas hazard controls, we have NFPA 54, NFPA 58, and NFPA 59. NFPA 54 covers fuel gas inside the buildings. NFPA 58 covers LP gas storage and distribution outside the building, while NFPA 59 applies to utility LP gas plants. People usually phrase that 58 at the gate and 54 under the floor. So clarity between them ensures proper application. On summary of the LP gas hazards, LP gas, which has the UN number 1075, is a flammable liquefied fuel used for cooking, heating, and industrial, and also transport. Although it's not toxic, it can displace oxygen, leading to asphyxiation in confined spaces. Its vapors heavier than air, which travel along floors and accumulate in basements or pits, posing a serious explosion hazard. LP gas stored in liquid under pressure in cylinders or SME tanks equipped with relief valves and fusible plugs, and when exposed to external heat, internal pressure risk rises, and risk, I believe, which is the boiling liquid expanding vapor explosion. NFPA 50 requires minimum separation distances, thermal protection, and water spray cooling where fire exposure is possible. And we have two different hazards within containment and hazards when released. In containment, the main hazards are overpressure from heating, overfilling, and failure of relief devices. A confined ignition may cause container rupture or belief. Preventive measures include correct filling ratios, pressure relief maintenance, and temperature monitoring. While the hazard from release, when gas escapes the confinement, formation of flammable vapor clouds capable of flash fires or deflagration, and potential detonation of gas accumulates in confined space, just like what happened in the accident in Arad. Asphyxiation by oxygen displacement, and proper leak detection, ventilation, and automatic shutoff valves are essential. This is why Bahrain Fire Code now mandates gas detectors and emergency installation even in low risk occupancies. We require it in every restaurant that use LP gas systems. And highlights from NFPA 58, Chapter 5 LP gas equipment and appliances, which concern the construction, design, and listing criteria. Chapter 6 installation of systems, piping materials, location clearances, and valve arrangements. Chapter 7 LP gas liquid transfer, safety during cylinder filling and bulk transfer. Chapter 8 cylinder storage and exchange, cabinet design, ventilation, and signage. Together they provide the framework for engineers, contractors, and inspectors to design and verify safe LP gas installations. So, as a summary, we should only use listed approved components and trade technicians, maintain required separation distance from building and ignition sources, conduct regular inspections and maintain training records, ensure emergency shutdown devices, pressure relief systems, and coordinate between NFPA 58 and 54 to avoid enforcement gaps. So yeah, that concludes the last of my industrial hazard presentation. And thank you so much for listening for this overview of NFPA 58.